Welcome, friends, to DEKB7QHC, an episode introducing a set of three topics that are all interrelated. I'm going to start this with BalUns. BalUns. The full expression is properly balanced to unbalanced transformer. And having introduced BalUn, we can vary these terms. We can have an un-un, which is to say an unbalanced to unbalanced transformer. Or, well, unbal is just the opposite application of a BalUn. Or a BalBal, which is a balanced to balanced transmission or transformer. And BalUns are either air core or used with ferrites. So that's the next topic is ferrites. Ferrites are used in they're widely diverse applications of ferrites. Some that come to mind are just power transformation, much like out of the wall over here, go into a transform. Yes, so there's ferrites that meet that application, but we're not talking about this when we're talking about BalUns, un-uns, or BalBals. We are talking about the ferrite as a bulk resistor. That's right, a bulk resistor to RF. Now, seeing that let's see, we have three parts. The transmission line is the third topic. And the relationship between the transmission line and the ferrite yields us a BalUn, un-un, BalBal configurations, depending upon the transmission line going through the core and then going through it again, being broken out and going through separately and being recombined to a load. There's a lot of weaving of hands there, and there's a lot of coverage on how to wind BalUns and with ferrites. This will be more of it, but suffice it to say that if you think of this of the ferrite material as a RF resistor or RF impedance, this is why I jumped into the transmission line. If we think of it as an impedance, we can think of it in terms of transmission line impedance and how the transformation is managed to yield a balanced to unbalanced transmission line. In other words, the BalUn is separating two circuits, and it's separating them by resistance. So your transmitter and your antenna, they have differences of power transmission, and at this point we isolate the antenna from the transmitter, and we solve the problem of the match at this point. So think of this point being a resistor between the antenna and the transmitter. Okay, so we have a BalUn that appears to be a resistive element between the source and the load. How do I achieve contacts with this? I was sold that a BalUn would achieve a match to something that was a higher impedance, or certainly lower impedance, but most hams don't go in that direction. They go up for end-fed wires that look like a K-ohm, and they need to step that 50 ohms up to a K-ohm. Well, you do that with BalUns, certainly. Very specialized ratios. And if you think of that as a turns ratio, no, it isn't. There are turns, yes, but it's not the ratio of 1 turn to 10 turns giving me a tenfold increase of impedance matching. No, no. There's other principles at work here, and we'll go into that later. Like I said, this is just an introduction. But the introduction is to keep these 3 principal points key. That is what we call a BalUn or an UnUn or a BalBal. What it's to achieve, it's a match of impedances. We're not thinking in terms of matching in terms of tune. This is matching in terms of impedances. The ferrite, which is most often, it's simplified. You can do this using air. Everything tends to be much larger, however. We use ferrites to compress this into a manageable size and to be consistent and not be affected by stray interactions with other structures that you might find with the air core style. Air core has to be rather more deliberate, but the ferrites are almost plug and match until you get what you need. So its resistance as a means of separating your antenna load from your transmitter source, and you need that isolation, without losing power. Without losing power. Well, how's that done? Well, this is part of the games with the ferrites. They're an RF resistor to common mode currents. So if you have a donut of ferrite and you pass a twin lead through it, the twin lead sees absolutely no resistance whatever from this bulk ferrite. However, I need to draw these things out. As this is an introduction, I'll show these in illustrations later, but suffice it to say that the current, a balanced current on a balanced line has no problems with the ferrite that it goes through. However, if there's an unbalance in those currents, and that almost every antenna application out there is an unbalanced problem from the start. When you have unbalanced currents between the two sides of the transmission line and ground, that's a third pole, that line of electrostatic connection, when the twin lead goes through the core, that common mode gets cut. And that's the resistor part of this at work. Like I said, sounds like a little bit of magic and fairy dust, but I'll have plenty of coverage on this to show you how to build your BalUn, and there's plenty of material, so I'll cut it short here, or cut it long, as the case may be. 73 is all.